Hello and welcome to this course on iOS development using iPhone. Well, so first of all, what is iOS? iOS, which was previously called iPhone OS, is just an operating system that we develop mobile apps for on iPhones, iPads, iPod Touches, and it's also used on second-generation Apple TV devices. iOS really is derived from OS X, and it makes use of existing frameworks. There is some renaming, there is some bridging between classes, but iOS really, at its core, is OS X. We develop for iOS, we develop for iPhone in an application called Xcode. This is an integrated development environment, and we use a language called Objective-C primarily. We can also use C++, something called Objective-C++. But in this course, we concentrate on the use of Objective-C. So, next question. What is Objective-C? It's an object-oriented superset of the C programming language. So if you know C, you'll find it very simple, mostly, to branch over into Objective-C. Anything we can say in C, we can also say in Objective-C. We have all the primitive types, we have arrays, we have structs, we have everything that we have in C, including pointers, but we add a layer of syntax to declare and define classes and instantiate them as objects. And if you don't know anything about object-oriented programming, that's okay. We're going to cover that using Objective-C as a springboard. But I will say, as a preview, that classes contain properties, which are data members, and methods, which are operations on the data inside the class. And this is something like the notion of a C struct, if you already know C. A C struct has properties, of course, but it doesn't have a way to add methods to that struct. Now, we can, if you know C, we can have things called pointers to functions, which is kind of like that idea. But object-oriented programming levels all that out so that the properties and the methods are both first-class citizens of a class. What are you going to need? Well, you'll need an Intel Mac running OS X version 10.7 or later. You're going to need a copy of Xcode. This is free. You can download this from developer.apple.com. This is the IDE that we use to develop for OS X and iOS. If you plan to develop applications for the App Store, you'll need an Apple Developer account. And that Apple Developer account gets you some other benefits as well. You get access to the developer forums. You get some other benefits as well there. Lastly, you will need some basic familiarity with a C-like programming language. C would be best, but any language that borrows syntax from C would be all right. So let's jump into actually what we're going to study in the course. The first thing we'll do is review C programming language. And then we'll have an introduction to Objective-C. We'll talk about classes and objects that we derive from them. We'll talk about properties and methods that we've already mentioned. And we'll talk about some important classes that are already there for us within iOS in what's called the Foundation framework, and other frameworks as well. We'll talk about some important design patterns that we use in iOS development. These are model view controller, delegation, target action, among others, but those are the big three. We'll talk about the life cycle of an iOS application, what happens when it starts, what happens when it shuts down, if it shuts down, and so forth. Application organization is a very big subtopic within iOS programming. As I already mentioned, model view controller is the design pattern that we use to design and build iOS applications. Anything else really doesn't work as well because iOS itself, the frameworks themselves, are designed with this design pattern of model view controller in mind. We'll talk about the user interface. Design user interface elements using Interface Builder, which is a piece of Xcode that formerly was a separate application, but now is wrapped in with the entire IDE. We'll talk about wiring controls to methods in Interface Builder, which saves us a lot of work. We can create a control programmatically and then wire it to a method as a callback would be wired, but we can actually graphically drag and drop from a control into a method in our code to tell our application to execute particular code when we interact with a particular control. We'll talk about something called a view controller and how a view controller works with a view. Again, we're talking about model view controller, and we're talking about the controller and view part of this. We'll talk about data models, which is the model piece of model view controller, and how that works with our view controllers. We'll talk about a special type of view controller that is used again and again in iOS applications, and it is called the navigation controller. Navigation controller is a very neat thing where we have a stack of views, and we can push views onto it, pop views off of it, and go through an application in a hierarchical way using a navigation controller. Table views are also very frequently used in iOS programming. Table views present a list of items. It is a scrollable list. We can select items from the table view, look at detail. We can add items to a table view and delete them. We can group table views. We can index them. Table views we can do a lot of stuff with. And so nearly all of Unit 5 will be talking about table views. We'll talk about structured query language and a subset of that called SQLite 3. And this is a lightweight database that is used on mobile devices. And then we'll go back and talk about Model View Controller in preparation for developing what we're going to call a case study application. And again, Model View Controller is the design pattern upon which iOS development is based. And we'll look at Model View Controller in the context of everything that we've studied to that point. We'll talk again and specifically about modeling an application's data, our case study application, in both discrete classes in a class graph and in SQLite 3 so that we can store it either on the device or offline. And then we will build a complex user interface to interact with our more complex model. So these are some things that we'll do beginning with our case study app that I'm going to talk about in the next slide. But we will add to this case study app the ability to record and play back audio and video. And we will also be able to draw, at the end of the course, you will understand how to draw 2D graphics using the core graphics framework, and also how to work with touchscreen events and drag and drop. Now this is a lot of information for an introductory level course, so we have a great deal of information to assimilate. So beginning in Unit 6, we'll present the new material that we haven't talked about thus far in the context of a single app, a case study that we'll build over multiple sessions. And in this course, that case study is called Parts Room. This may sound boring, and I guess maybe it is, but it's an application to list parts and inventory and create assemblies of multiple parts for an asset management or manufacturing application. We will build this application. It will be unfinished. We're concentrating on specific tasks that we'll use to build and design and work with applications as they grow. We're not really concentrating on an application in its finished state. So finally, we'll summarize the course, and we'll have a presentation on some best practices for application design and development. We'll also talk about presenting an app, taking it to the App Store, deploying it, and some other things along the way. So we have a great deal of information to cover. Take it one step at a time. Look at all the demos, do all the discussions, and let's get started. Thank you very much.